There was one more story problem. We had kind of just started this one, and then we halted because we got to the end of the period. I did want to go through and do this one with you just because it's got these percents in here, and I feel like that's an important component because a lot of times when they throw percents into problems, we're not quite sure what we're doing with them. And there are some problems like this. I know there's at least 2 problems in your review for the final packet that are story problems. So help me pick out the important information and tell me what you think we should do with it. If you just want to start off with picking out the important information, that's fine. We don't have to do anything with it right away. Yes, sir.
Would it be like all the numbers, like the 750,000?
750,000. 12%, 8%, and 4%. 4% wasn't there on Friday. I realized that had been unintentionally left out. And so I apologize. Twice as much, and 820. Okay. So we've got our numbers figured out. What is it that we are wanting to know in the end?
How much money they should invest, or like the beginning amount.
How much money they should invest where?
In both of the things.
Both of the things. What do you mean by both of the things? We've got low risk stock. We've got high risk stock.
Yeah.
Is there anything else that they're considering investing in? Government issued bonds. That piece was missing on Friday, and so I apologize.
So it's kind of like chickens have 2 legs and cows have 4 legs. How many cows are chickens?
So
right?
Well, that's the I remember.
Yeah.
Start systems of equations. That's what this one.
Yeah. All right. I'm going to use H for the high risk stock. What about the high risk stock are we wanting to know? What do I want to know about the high risk stock?
It has annual rate of return of 12%.
Yes. That's something I know about it. What do I not yet know that I want to know? Because that's going to define my variable. That question at the end says, how should the money be invested? So when I'm talking about the high risk stock, I want to know
End value.
not necessarily the end value. I want to know how much they should put in there. How much should they invest in the high risk stock? So the amount invested in high risk. What other variables do you think I need?
The low risk and the government issued.
Low risk and the government issued bonds. So I'm going to call them L and B. So again, it would be amount invested. I'm not rewriting all those words. In low risk. And the amount invested in the bonds. You guys okay with my definitions for our variables? If we don't know what the variables are and we don't know what the variables mean, we're not sure what we're looking for. I'm going to use these variables and the other information that they gave me in the problem to finish solving this. System of equations, absolutely. Tell me an equation that we could write from the first piece of information that you guys told me was important. Even before then. What was the first thing that we circled? 750,000. That's the amount that they are planning to...
Equals H plus L plus B.
Yes. What we put in the high risk account plus what we put in the low risk account plus what we put in the bonds has to all add up to 750,000.
And then
You're gonna do
820,000 20,000 equals H times 0.12, L times 0.8, and B times, there's 0. Yeah.
Would they be added?
Or times 1 point, whatever, yeah.
Yes. What'd you say?
Do you take the difference between the two? Like,
I would take the difference between the two, because then we can leave the 1 point off on these things. So if I do 820,000 minus the 750,000, how much? 70,000. What does that 70,000 represent? What they made. That's the interest from the first year, right? Interest in first year. Brendan, what you were suggesting could also work. You could do 1.12H plus 1.08L plus 1.04 equals that 820,000.
Yeah.
That would absolutely work as well. What is the interest on the high risk? 12%. So 0.12 for the high risk. Plus, what is the interest on the low risk? 0.08 for my low risk. What about the government issued bonds? Yep, 0.04. B equals 70,000. Is there any other information that we have to work with?
it says twice as much in the low risk as in the high risk.
Twice as much in the low risk as in the high risk. So if I know how much we're putting in the low risk, if I gave you that amount, could you tell me how much was invested in the high risk?
Yes.
What would you do to it? Which one is doubled?
The low risk. So T to the L equals H or something like that.
Think about that equation before we move forward with it. What does this say?
If you multiply the amount that you got at the end from the low risk stock by 2, then you would get the amount that you would get from the high risk stock in only 1 year.
Except for the 1 year part, 2 year part, because we're talking about our initial investment. But yes, it says multiply the low risk by 2 to get the amount in the high risk. Is that what it says in words? Which one has more money in it? The low risk. If I take the amount on the low risk and I double it to get the high risk, which one has more?
The high risk.
The high risk would have more if we take the low risk amount and double it. So what should my equation look like if the low risk has more, twice as much more than the high risk?
2H equals L.
2H equals L. This says 2 times the amount in the high risk equals the amount in the low risk. Does that make sense? We said the high risk account has less in it. The low risk account has more in it. I like this one a whole lot because what's that going to allow me to do in my other 2 equations? Yeah, I can substitute 2H in the place of L, and then I'm going to get it down to just 2 variables instead of 3. So I'm going to substitute. I'm going to keep the H. Instead of L, I'm going to replace that with what? 2H plus B equals 750,000. And then in my other equation, again, I'm keeping the h, 0.12h, plus what? 0.08 times 2h plus 0.04b is equal to 70,000. So that top equation becomes what when I simplify it? 3h plus b is equal to 750,000. What about the one below it? The middle would be 0.16. So I get 0.28 when I combine those together, right? So 0.28h plus 0.04b equals 70,000. And then from here you can decide whether you want to use substitution or linear combination, the elimination method. What would you guys want to do? Linear? Okay. What would be the easiest way to use linear combination here?
Maybe multiply, maybe top equation by negative 0.04.
Yeah, I think that would probably be the easiest. If we're going to use the linear combination method, I agree that that's probably the easiest way to do it. Multiply the top equation by negative 0.04. Where did this y come from? Oh. Huh. Trying to give myself a little bit more room to work with here. All right, times negative 0.04. What's 3 times negative 0.04? Negative 0.12h minus 0.04b equals 750,000 times negative 0.4. How much? Negative 30,000. And then I'm going to combine these two together. So I have, what is that, 0.16h equals 40,000. I'm trusting you guys on these numbers here. Let's double check our numbers. Got 30,000 there. 0.04 times 3. There we go. I think I just entered my division in there incorrectly. Divide both sides by 0.16. And that means our high-risk account is how much? $250,000. So we got the high-risk account. We still have 2 to go. We need bonds and low risk. Low risk is half as much? Yeah, low risk is twice as much, so we're going to take that and times it by 2. L equals 2H. So the low risk account would be how much? 500,000. And we know that all 3 of these added together have to be what? 750,000. So how much in bonds? What'd you say, Amaya? None. They decided not to put any in bonds.
What? I'm trash. Maybe they hate the government too.
Alrighty. We've got the rest of the time to work on whatever you guys want to talk about or look at from your review.
I got a question. I mean, I haven't started it, but that's not the point.
That's fair.
It's just, well, I went through at least, and I circled stuff that I'm probably going to practice on. I do not remember how to do these.
25?
Yeah.
Absolutely, we can look at that.
'Cause I know how to do this.
Mhm.
Just the adding, subtracting.
So I'm so glad you brought this one up. This one, I'm actually going to be emailing the IU professor about. Because after a long conversation with a former professor of mine, it's not really possible. Well, not that it's not possible. It's not obvious from the ranges of the original functions to be able to tell what the range is after you perform an operation on it. So all that to say that on number 25, don't worry about finding the range. We can find the domain, but don't worry about finding the range.
You should have signed for number 21.
Number 21. Probably. Is that the one with the rational?
Yeah.
Yeah, you don't need to do the range for that one either. I'll be honest, I'm not entirely certain why. Like, I patterned what they were asking for, like all the things that I asked you to list based on some of the different sample questions IU sent me. Okay?
You already have a final?
Yes, I do already have the final. I patterned what I put on here, like you should be able to list these things off. When I sat down and worked through not only the final, but through my review, I started running into some things, and that's why I contacted my former professor who has 2 doctorates in math.
That's what I'm saying. She needs to contact the professor. It doesn't need to be on our test.
Well, I'm like, am I just crazy here? Am I missing something? Is this easier than I'm thinking? Because if I'm really struggling with it, it's either because I'm having a brain dead moment, which happens. That's valid, right? All I wanted was for my former professor to be like, didn't you remember this? And I'm like, oh yeah, and I taught them this already. If it's not something that I've covered with you guys, and it's not something that I can figure out, I'm going to contact him. And he and I worked it out, and he's like, yeah, no, here's the proof for why you're right. So, I'm really confident about this one. We're not going to bother with the range. Domain, yes. Domain is a fair question. Range is not. For our function operations, the first 4, we're just going to be performing whatever operation they ask us to do. So I'm going to copy down my function k. What is my function k? 2x minus 1. And I'm going to add that to my function h. What's my function h? Negative 1 over x plus 4 squared. If I add a negative, what happens? Yeah, it's going to turn into subtraction there, right? So I have 2x minus 1 minus 1 over x plus 4 squared. How do I actually subtract these things? What do I need? I need a common denominator. So I'm going to take all of this right here, and I'm going to multiply it by x plus 4 squared over x plus 4 squared, because that's the same as what? That's the same as 1. So I'm not actually changing that first value because I'm just multiplying it by 1. So I would have x plus 4 squared times 2x minus 1 over x plus 4 squared minus 1 over x plus 4 squared. Can I actually combine these things together now? Yes. What would I get when I combine them together? We don't need to double, triple distribute. Just tell me what the top part would look like. Yes.
Or minus 1.
Minus 1, yes. All over x plus 4 squared. I am perfectly okay if you leave it like that. That is fine with me. For my domain, the domain has to meet the restrictions of both of those original two functions. So I need to know what the domains of the original functions are, because then I need to know where those things cross each other. I heard a really good example of this as I was doing a little bit of research to make sure that I wasn't wrong on how hard it is to find the range here. When I'm thinking about the domain after I put these two together, it's kind of like hosting a dinner party. Whatever restrictions the first function has. So if I'm inviting somebody to my dinner party that can't have nuts, I have to make sure that none of my dishes on the table have nuts in them, right? If I also invite somebody to my dinner party that can't have dairy, they're allergic to dairy, I need to make sure that nothing that I'm serving has dairy in it, right? So nothing on the table can have nuts or dairy, but everything else is okay. So any restrictions there are on the first function, I have to bring down. Any restrictions there are on the second function, I have to bring down so that when I put them together, it's okay for everybody. Does that make sense? What is my domain for k of x? Tell me all the things I'm allowed to use for x here. Everything. My domain here is all real numbers. Anything I want. Is that my domain for h of x?
No.
What's my domain over here? Yes. The only thing we can't have is -4. That breaks my denominator. Everything else is okay. Does that first function k of x have any restrictions on it? No. So when I'm inviting both functions over, what's the only thing I have to watch out for? -4. So my domain here, when I add these together, is just x can't be 4. Yes, -4. My bad. X can't be -4. But it does help us understand why we have to leave certain things out. Thank you. So our domain down here, -∞ to -4, union -4 to infinity.
I have a question.
Yes.
So for x plus 4 squared, the only root that comes out is a -4.
The only thing that x can't be is -4.
Oh, okay.
when we're talking about domains. If we're talking about ranges, the conversation gets a lot more complicated.
Okay, yeah,
Yep. All right. How would I approach part B?
Similar way.
Almost the exact same way. What will the only difference be? Yeah. Right here, I would put subtraction instead of addition. Are you guys okay if I skip that one and leave that one for you to do now that we've done the addition one?
Yep.
Okay. Do you want to talk about part C? It's multiplication. What things am I multiplying together? Yep. 2x minus 1 is getting multiplied to negative 1 over x plus 4 squared. How do we multiply these two things together? Are they both fractions? Can I make the first one a fraction by putting it over 1? How do we multiply fractions together? Straight across. So I'm going to multiply top to top. I have 2x minus 1 in my numerator. I've got that negative sign out in front. And I have x plus 4 squared in my denominator. Yes, Jacqueline?
We need to distribution, like whenever we need to do it, just do the operation, and we need to do this.
For this over here, I would not worry about it. I wouldn't worry about that at all. You can if you really, really want to, but they just asked me to add them together. That is showing me those two added together. If I wanted you to do something more with it, then yeah. One of the reasons why we've distributed in the past is to make sure that it's fully simplified, that everything that should cancel does cancel. In this case, the only thing down on the bottom that could cancel is an x plus 4. If I distribute this, and then I distribute it to this, and I subtract 1, I'm going to end up with a cubic equation, and unless it's perfect cubes, I don't know any roots of it. Like, it would get so complicated to see if x plus 4 was a root. Does that make sense? I'm not going to ask you guys to spend a half an hour on one problem. That would turn into a half-hour-long problem. Because we have tools now to know whether or not that's a root. We could multiply it all the way out. We could use our factor theorem. We could do synthetic division with negative 4. But that's a lot of work.
So if you don't say that it's full distribution, we don't need to worry about it, right?
And on the exam, if you wonder about it, raise your hand and ask. Do I need to distribute this all the way out? I'll tell you yes or no. Okay? If there's any questions that you have like that about whether or not I would expect that, you are welcome to raise your hand and ask me. Talk to me about D. It's division time. What's on top? What's on bottom? 2x minus 1 is on top.
1 over x plus 4 squared.
On the bottom, I've got negative 1 over x plus 4 squared.
We can do keep change flip, right?
Yep. Keep change flip. We are dividing by a fraction. That's the same thing as multiplying by its reciprocal. So I would have 2x minus 1 getting multiplied to negative x plus 4 squared. Technically that's over 1, but do I really need to keep it over 1? No. So if I simplify this, what would I have? I'm not asking to like double, triple distribute here. Is there anything that I can easily clean up about this so that it looks better than with? Yep, negative out in front, 2x minus 1, x plus 4 squared. What would my domains for C and D be?
The same thing as
C is the same thing.
and D is all of
Remember, it has to inherit the domains from the original functions. If it's not in the domain of the original function, I can't have it in my end result. So what would my domain on D be? Yep. Same thing here. If this was the only thing I was looking at, it would be all reals. But because I had that original function that had the restriction on it, that has to come down. Does that make sense why? I can't put something on the table that has pieces in it that somebody who came to the party can't have.
So once you have that restriction, it's for all of it.
Yes, once you have that restriction from the beginning, it has to apply to all of them. We might pick up some additional restrictions along the way, but it has to have any restrictions that were present in the beginning.
So,
Mhm.
so is the restriction that we have in the top at the same time that we have in the equation, or
Mhm.
that we have in the top? Like,
Anything up here? Any restrictions here, which in this case we only had the one restriction? That has to come down for here, for here, for here, for here, and it has to be here also. These two we have to look at a little bit further. Hold on, let me fix this. These two we have to look at a little bit further because here, grabbing this restriction, since it's got division, it's possible that I could end up with a divide by zero error that I didn't have back here. Let me give you an example of that. We'll come right back to this. But I want to give you another example that might make that a little bit clearer. If f of x is 2x minus 1 and g of x is 3x plus 5. Let's even make it easier, just x plus 5. If I had something like this, do we have any restrictions here? Any restrictions here? But when I go to divide those two functions, f divided by g of x, what does this look like?
2x minus 1 over x plus 5, and you can't use the negative.
This has a restriction. Neither of those had a restriction, but here I have a new restriction that popped up because I have that divide by zero problem. That's what I was trying to point out. For addition, subtraction, multiplication, it's just any restrictions on the original come down. Any restrictions on the original come down, any restrictions on the original come down. Here you got to look for one more. Do I end up with a divide by zero error when I do this division? Alrighty. And then we still had composition yet. How do I compose these two? What does that mean? Yes, k of h of x. So I have 2 on the outside. And we have our function h of x on the inside. So I'm substituting h of x in the place of x. Minus 1. Can I clean that up at all? Yep. What would that look like when I cleaned it up? Yes, negative 2 over x plus 4, whole thing squared, minus 1. They asked me to do the composition, so I don't need to actually go further and get that common denominator and combine them. I composed them together. I'm good. What would my domain be here? Same thing as the others, right? Absolutely. This is another one where you have to watch out for some things sometimes, because whatever this one spits out is going to go into k of x. So if k of x has any restrictions, I have to make sure that this wouldn't give me something that can't go into k of x. Yes,
So
ma'am?
if you have a new restriction, why you put in the domain? Like if you have one that is in the previous case, and after you find a new one, why you put two that is in the domain?
Let's look at that. I'm going to come up with two new functions. We're going to have f of x be 1 over x, and g of x is, let's keep just x plus 5, right? In this case, if I go do f of g of x, what would that look like? 1 over x plus 5. This function right here doesn't have any restrictions on it, right? But when I take that, is there any kind of output that I could get from that that would break this? -5. So in this case right here, I need to look at the domain of g of x and the domain of the result, which in this case would be this. If g of x had restrictions on it, things that it could not be, then I can't use that as input in the first thing. And then if it has an output that can't go into f, that would be another restriction. I don't actually care about the restrictions on f when I do a composition, because the things that are being fed into f come from here. Only the output of this gets fed into my function f. Does that make sense? A little bit? Tiny bit? Okay. Did you guys have any other questions for me? Yes, ma'am. Which one? Number 2? Absolutely. And this is a fast one, and so we've got just enough time to cover it too. A function which is symmetric with respect to the x-axis. Or sorry, a relation. What would it look like if it was symmetric with respect to the x-axis? Yeah, it's got to be like the same top and bottom, right? So something like this, or something like this. You're right, it's not a function, but they told me to write what? A relation. Specifically didn't use the word function, because if it is symmetric about the x-axis, it can't be a function. Because same x would give you two different y's. If I were to write something like this one right here, it's a parabola, right? But it's on its side, so this isn't a y equals, it is x equals. X equals y squared would give me something that is symmetric about the x-axis. What about if I wanted to do, this time they did use the word function, symmetric about the y-axis only? Yeah. Would a parabola work here? Yeah. I could do something like this. I could do like an absolute value function. Now I'm looking for mirror images on the left and the right, not above and below, but left and right.
You can do a line.
You could do a line. Would that be the same if I folded it across the y-axis? Yeah. So we could have y equals absolute value of x, y equals x squared, y equals 5. Those would all be examples of things that are symmetric with regards to the y-axis. So mirrored on either side of the y-axis. The other one would be mirrored on either side of the x-axis. I'll take more questions tomorrow. All the answers, without the work, but all the answers will be up today after school. I'll take any additional questions, and tomorrow after school, I will make sure that all of my work is up. So if I wasn't able to get to one of your questions, you can still get in and see all of my work for any of these problems. One other thing that I can tell you, I promise you that this review is harder than the exam. For real. The review is harder than the exam. So if you work through these questions and you get yourself to a place where you're comfortable with knowing how to answer all of these, you'll be fine.